This is TempleOS 5-minute random code walkthrough episode 62, and I'm your host, Terry Davis. And where did God take us? Looks like we're in the compiler. We are in the compiler optimization library. Okay, this looks like, yeah, that's what it is. Okay, so this is there are two routines: optimize branch not zero and optimize branch zero. Optimize branch zero, and down here is optimize branch not zero. And what this does is when it hits a branch not zero, it checks the previous. Okay, so temp I is the current intermediate code. Temp II is the previous one. To see this in action, let's if I equals, I don't know. Okay, so we have we start with we dereference the I local variable, and then we push on the stack the I, then we push 3, then we say equals equal. Is it equal to 0? And then that's the comparison, and then we branch if 0. So we want no, well, I don't know, let's see. Branch 0. No, that's not what we want. Scheist. Okay, so I'm trying to get the exact. This is doing branch 0. There should be some way to get branch not 0. Oh, I know how to get branch not 0. No, it's still branch 0. We have a not. Then, okay. Well, anyway, we want to convert to a branch less. Pass 0, 1, 2 converts it to a less than. What it converts is not. You see, the less than pushes either a 1 or a 0 for true or false. Then it takes the then it inverts it, and then it branches if not 0. Anyway, so now that we know what's going on, whoops. I'm going to post that one time. Okay, so less than then branch not. Let's get rid of it. Okay. Now we have less than and branch 0. So I'm going to look at the branch 0 or branch 0. Okay, so if the previous one is a less than, that's what we have. Then what we convert to is branch greater equal. So branch greater equal, that's pretty weird. Is that actually what happens? Yeah, actually branch greater equal. Okay, so branch 0 is false. Branch if false. branch 0 is branch if false. So if less than is false, that's the same as greater equal. So it converts it from two opcodes, less than and branch 0, to one opcode, branch greater equal. And if we get another thing, these optimizations will check flags. So let's say we want to see if we want to bit test, let's say bit test and set. This is a bit field, bit 0. So if we so we have now it's a function call. So here's the function call from start to end, and this is several opcodes, and it has a bit test and set. What we do here is if it's a call end, then we check an extra, a previous one, and if it's bit test and set, we convert to branch bit test and set, and so forth. Anyway, so the way these work is if it doesn't get converted, if it's still branch 0, well, what we do is we convert the opcode, and so if it's not branch 0, it has been converted, and we have to nuke the previous one. It went from two opcodes to one opcode, so we nuke the previous one, and then we check for we can technically we can have one less than I less than. We can have something like this, and that has a push compare. So we check for that here, and I forgot. I think anyway. We can. Okay, if we have and this does short circuit logic. So in order to do short circuit logic, if the I forgot. Anyway, this does short circuit logic, and then the other interesting point is if it's a not, then we these two routines are they call each other. You see where it says branch not 0, so now we're down to this other routine, and if this one is a not, then it's branch 0. So this basically if we have let's say we have something like this, those routines will convert the knots to anyway. Oh well, how about that?